Yes, students, welcome to the next video lecture. In the previous lecture, students, we have studied the concept of subset. Let us revise the definition of subset. For any two sets A and B students, if every element of A is also an element of B students, then we say that A is a subset of B. Now, students, we have studied the definition of subset in terms of logic also. That if small a belongs to capital A implies small a belongs to capital B students, then we say that A is a subset of B. The logical form of definition, students, the definition of subset in the form of logic, students, is especially used in prove that sums. We'll use it in exercise 1, students, so you are advised to remember that. Now, students, if I start with question number 2 of exercise 1.3, students, following statements are given and we have to identify whether the statements are true or false. Now the first statement is set A B not a subset of set BCA. Okay, students, set of elements AB not a subset of set of elements BCA. This statement is false because set AB is a subset of set BCA. Very simple. Then AE subset of X such that X is a vowel in English alphabets. Now the first set is AE and the second set is vowels in the English alphabets, which are A, E, I, O, U. Definitely A is a subset of second, so this statement is true. Third, 1, 2, 3 subset of 1, 3, 5. 1, 2, 3 subset of 1, 3, 5. Definitely false. Then, fourth, singleton set a subset of ABC. Of course, true. Then, fifth, singleton set A belongs to set ABC. This is 100% false because singleton set A is a subset of set ABC. It is not an element of set ABC. Then last question, students, we are doing orally. X such that X is a even natural number less than 6. Even natural number less than 6 includes 2 and 4. And X such that X is a factor of 36. X such that X is a factor of 36. Factors of 36 are definitely 2 and 4. 36 is divisible by 2. 36 is divisible by 4. So it is true. So directly we are writing sixth statement is true. Now, students, in the same fashion we have the third sum, students, and there also we have to justify whether the given statements are true or false. And students, we have to understand it very perfectly because this question is very important. Okay, so let us start with the third question, students. Now set A. Be careful about set A. Set A consists of elements 1, 2. Then set 3, 4 is an element of set A and 5. So mind you, only 3 or only 4 students are not elements of set A. Set 3, 4 together is an element of set A. So one has to be very careful. Now the first question only I told you set 3, 4 is an element. A set can be element of another set. So be very careful. So when I take only set 3, 4, it is an element. So the first two questions. Set 3, 4 subset of A, and second is set 3, 4 belongs to A. Now be very careful. If I name this set as B, then B is an element of set A. So always B belongs to A. So the first statement tells that B is a subset of A. No, set B is a subset of set A. When I write B in a set notation, then students, it becomes a subset. So the first three questions, check. It is set 3, 4, again in a set, then it is definitely a subset of set A. So students, one has to be very careful in answering this type of question. So here it is an element. For element, the symbol is belongs to. So this statement is false. Okay, B is an element of set A. So this statement is true. And set B, B written in set notation. Again, singleton set B. B written in set notation is a subset of A. Definitely, students, this statement is true. So here one has to understand the basic, students, very perfectly. Check these three questions once again. These questions are very interesting. Set B is an element of A, so subset false. Belongs to A, yes, because for element it is always belongs to. Set B written in set notation will be a subset of set A. Of course, a singleton set. Now 1 belongs to A. Question 4. 1 belongs to A. True. Because 1 is an element of set A. 1 subset of A. False. This statement is false. Because 1 is an element of set A. Then 1 to 5 subset of A. Absolutely right. Set of elements 1 to 5 is subset of A. Correct. There are 4 elements, 1, 2, 3 and 4 elements of A. So number of subsets of A will be 2 to the power 4. How many? 16. And 1 to 5 is one of the subset. Then students, 1 to 5 belongs to A. Question 7. Then students, 1 to 5 belongs to A. Definitely false. Because this set is not an element of the set A. Then 1, 2, 3 subset of A. Set of elements 1, 2, 3 subset of A. This is also false. Because only 3 is not an element of set A. I told before also. Only 3 or only 4 are not elements of set A. So this is false. Null set belongs to A. No, here null set is not an element. So this statement is false. Then 10th, null set subset of A. Correct. Every set which is non-empty will definitely have null set as a subset. Singleton set 5 subset of A. Singleton set 5 subset of A. This is also false, students. Why? Because 5 is not an element of A. 5 is subset of A. So singleton set 5 cannot be subset of A, students. So this statement is false. So these are very, very logical questions, students. You have to understand these questions very, very perfectly, students. One mistake in the understanding will give you wrong answer. So check. 1 to 5 belongs to A. It is false because set 1 to 5 is not an element of A. Now 1 to 3 is subset of A. That is also false because only 3 is not an element of A. So students, be careful in understanding this type of questions. Now students, the next topic, the next concept, students, it is, you can say, number of subsets and power set. Students, the next concept is regarding number of subset we have already discussed, and what is power set of a given set. Then we will discuss the question. Now students, what is the power set? how to define power set. Say we have any non-empty set A is equal to AB. Now this I already explained in the last lecture, that if a non-empty set A has n elements, number of subsets are 2 raised to n. So number of subsets of A is equal to 2 raised to n is equal to 2 raised to 2, and that is 4. So if a non-empty set A has n elements, students, number of subsets of A are 2 raised to n. Now if I want to write all the subsets of set A, then the first subset is null set, then singleton set A, then singleton set B, and then set AB. So first of all, students, what I am doing, I have listed all the subsets of A. If I keep all this subset in a set, then that set is denoted as power set of A, denoted by P of A. If I keep all the subsets of A in a set, then the new set formed is called power set, students, of the given set A. So if A is any non-empty set, the set of all the subsets of set A is called power set of A, students, denoted by P of A. If it was set B, then denoted by P of B, and if it was set C, students, then denoted by P of C. So indirectly, when we write power set, we are writing all subsets, but those subsets are written within a set. So every element of a power set is a set. What we have to remember, students, is this statement true or false? Every element of power set is a set, correct? Check here, each of these elements are set. So once again, how to define power set? For any non-empty set A, the set consisting of all the subsets of A, students, is defined as power set of A, denoted by P of A. It was set B, then power set of B, P of B. Power set of C, then P of C. Power set of X, then P of X. Now, students, the next question, question number 4. Write the subsets of all the following sets. Okay, students, let us do the first question. It is singleton set A. So exercise 1.3, question 4, part 1, say given set is singleton set A. Now for this set, the power set is denoted as P of A. Now number of elements are 1, so subsets are 2 raised to 1, that is 2. So one is null set and other is the set itself, that's all. Clear, students? Then second sum, it is, say if I write this as B, then this becomes power set of B. This is the second sum. Very simple, students, you can easily answer. Yes or no? Okay, then students, the third sum, it is having 3 elements, okay. So let us call the set as C, and C is equal to set of elements 1, 2 and 3. Number of elements are 3, so the subsets will be 2 cube, and 2 cube is nothing but 8. So if I write power set of C, then P of C will be null set, then singleton set 1, then singleton set 2, then singleton set 3, then set of elements 1, 2, 1, 3, then 2, 3, and set C itself. Instead of 1, 2, 3, I can write C also. Students, I know the question is to write only subsets, but we have done one step more to write the power set. If it was only subset, I would have not written this all in the set notation, that's all. But that you already studied in standard 8 and standard 9. That is why we modified the question a little bit and we wrote the power sets of all the given sets. Now the fourth is null set. It has no elements, so 2 raised to 0 means 1. So in the power set we will have null set only. That is easily students understood. Now in the fifth question they have given A is equal to null set. Then you can say how many elements P of A will have. Only null set itself, I told you. If your set A is null set, then the number of elements in the power set will be null set itself. So the only one element student. That is also very simple. So answer 5. If A is equal to null set, means no elements, so n is equal to 0. So P of A will have only one element, and that is null set. So P of A will have how many elements? 1, and that is null set itself. Now students, we are going to discuss one more important topic students, and that topic is called concept of intervals. And this concept of interval students is very important in mathematics, especially in JEE Mains and JEE Advanced and GUJCAT students. This concept of interval is very important students. So one has to be very careful in understanding the concept of interval. Let us do it students. It's very simple. Now students, types of intervals. In mathematics we have two types of interval. One is open interval, and students, the other is closed interval. Students, in mathematics usually we have two types of, you can say, interval. First is open interval and the second is closed interval students. Now let us understand this with an example first. Now say suppose if I write students x belongs to open interval 2, 5. Let us draw the number line. So this is 0, say this is 2, and say this is 5. Now if I say x belongs to this small brackets or simple brackets denotes open interval, means x includes any real number between 2 and 5 excluding 2 and 5. X cannot be 2, x cannot be 5, but x can be any number between 2 and 5 which is real number. Means it can be 2.1 also, 2.8 also, 3.6 also, 4.7 also, and 4.999 also, but not 5. So when I write x belongs to open interval 2, 5, it means x can be any real number students between 2 and 5. X cannot be 2, x cannot be 5, but x can be any number between 2 and 5. Now students, if I write x belongs to closed interval 2, 5, square bracket means closed and simple bracket means open. Students, square bracket means closed. So what is the difference? X can be any number between 2 and 5 stays correct, but x can be 2 also and x can be 5 also. So what is the difference between these two intervals? Here 2 and 5 endpoints are excluded, and here 2 and 5 endpoints are included. So if I say x belongs to closed interval 2, 5, which is you can say usually denoted by square brackets, x can be any real number between 2 and 5 and including 2 and 5. So x can be 2 also, x can be 5 also, or else students x can be any real number between 2 and 5. Don't make mistake of saying x can be integer. 2.1 also is a value, 3.7 also is a value, 4.882 is also a value. So those are not integers. So in open interval, endpoints are not included. In closed interval students, endpoints are included. This is the difference. Clear, students? And using this open and closed interval, I can make two more intervals, which is open closed and closed open. Say suppose I write x belongs to open 2 to closed 5. Means what? X can be any real number between 2 and 5 including 5, because at 5 it is closed. 5 is included but 2 is not included, so this interval is open closed. Or I can write x belongs to closed 2 to open 5. Then x is any real number between 2 and 5 including 2 but not 5. So basically two types of intervals, open and closed. Using this we can form two more intervals, open closed and closed open. This you have to remember, students. Now let us write the mathematical form of all these four intervals. Demonstrating the same example. Say suppose if it is 2, 5. Say students, if I have open interval 2, 5, then this includes element x such that 2 less than x less than 5 and x belongs to R. Means x is any real number between 2 and 5 excluding 2 and 5. Now closed interval 2, 5. This consists of elements x such that 2 less than or equal to x less than or equal to 5, x belongs to R. The only change is equality sign is added, because in open interval endpoints are not to be included, whereas in closed interval, students, endpoints are included. Then open closed, x such that 2 less than x less than or equal to 5 and x belongs to R. Then closed open, x such that 2 less than or equal to x less than 5, x belongs to R. Where simple bracket is there, we write only less than, and where closed bracket is there, we write less than or equal to. That you have to remember, students. Clear? All of you understood? So if I generalize and write here AB, then you write x such that A less than x less than B, x belongs to R. But if I directly write AB, students, you will not understand. If I write here closed interval AB, then x such that A less than or equal to x less than or equal to B, x belongs to R. If I write open A and closed B, x such that A less than x less than or equal to B, x belongs to R. And if I write closed to and open B, closed A and open B, then A less than or equal to x less than B, where x belongs to R. If you don't write x belongs to R, then mark belongs to 0. Be careful. You have to be very careful, students. Now let us understand the question 6, students. It is based on this only, that you can say write the following intervals. Write the following sets as intervals. Now students, the first is x such that x belongs to R minus 4 less than x less than or equal to 6. Question number 6. X such that x belongs to R, this can be written first or last. Minus 4 less than x less than or equal to 6. So where it is equal to, it will be closed, and where it is only less than, it will be open. So minus 4 is open and 6 is closed. So this is written as open minus 4 to close 6. That's all. This is your answer, students. Nothing difficult. Second, x such that x belongs to R. Minus 12 less than x less than minus 10. Both the sides are less than. Equal to is not there, so this is an open interval. So this is open interval minus 12 to minus 10. Students, always remember, in an interval the lower number is written first. Now third, come on, I'm erasing this. Third, x such that x belongs to R. Zero less than or equal to x less than 7 equal to is for 0, so 0 is closed and 7 is open. Fourth, x says that x belongs to R, and 3 less than or equal to x less than or equal to 4. Both the sides are equal to, so closed 3 to 4. So this is how, students, we apply. Nothing difficult. So these 4 samples I have kept on the board only, so that you can immediately check which is applied. And this is applied in this thing. Check. So students, your application part should be very sound, and you should be very, you can say, alert in applying the formulas. Now the 7th question is reciprocal of this. Write the following intervals in the set notations in property form. Open -3 to 0. Come on, what should I write? It is first. Question 7 part 1. Open -3 to 0. X such that -3 less than x less than 0. X belongs to R. Then students, closed 6, 12. X such that 6 less than or equal to x less than or equal to 12. X belongs to R. Then open 6 to close 12. So what we'll write here? 6 less than x less than or equal to 12. X such that 6 less than x less than or equal to 12. X belongs to R. And fourth, I am discussing orally. It is open interval -23 to closed 5. Sorry, closed -23 to open 5. Come on, what we'll write? X such that -23 less than or equal to x less than 5, and x belongs to R. So this is what is, students, regarding the concept of interval. You can easily write this: x such that -23 less than or equal to x less than 5, x belongs to R. -23 is closed and 5 is open. So students, this is what is regarding the basics of intervals. Remember this, students, in mathematics this is of, you can say, extra importance. Closed open, open closed, open interval and closed interval, students. One must be very thorough with the basics of this. So students, I think we are done with the today's concept. You have to study this lecture perfectly. Write all the definitions and set notations and symbols twice. In case if you have any doubt, you can call me personally or WhatsApp me, students. We conclude the lecture. Thank you.